Here, I'll step through the C++ code for the simple mover node and explain what's happening. First, the Rust header file is the official client library for ROS. It provides most of the fundamental functionality required for interfacing with ROS via C++. It has tools for creating nodes and interfacing with topics, services, and parameters. From the std messages package, we import the float64 header file. This package contains the primitive messages types in ROS. Later, you will publish float64 messages to the position command topics for each joint. Inside the main function, the ROS node is initialized and registered with the ROS master. rmover is the name of the node. Notice that the main function takes both argc and argv arguments and pass them to the init function. Then, a node handle object n is instantiated from the node handle class. This node handle object will fully initialize the node and permits it to communicate with the ROS master. Next, two publishers are declared, one for the joint 1 commands and one for the joint 2 commands. The node handle tells the ROS master that a float64 message will be published on the joint topic. The node handle also set the queue size to 10 using the second argument of the advertise function. Following, the loop rate object sets a frequency of 10 Hz. Rates are used in ROS to limit the frequency at which certain loops cycle. Choosing a rate that is too high may result in unnecessary CPU usage, while choosing a value too low could result in high system latency. Choosing sensible values for all of the nodes in a ROS system is a bit of a fine art. Next, we set start time. In a moment, we will use this to measure how much time has elapsed. When using ROS with simulated time, as we are doing here, ROS time now will initially return 0 until the first message has been received on the clock topic. This is why start time is set and polled continuously until a non-zero value is returned. In the main loop, the elapsed time is evaluated by measuring the current time and then subtracting the start time. The joint angles are sampled from a sine wave with a period of 10 seconds and in a magnitude from -π/2 to +π/2. Each trip through the body of the loop will result in two joint command messages being published. Due to the call to rate.sleep, the loop is traversed at approximately 10 Hz. When the node receives the signal to shut down, either from the ROS master or via signal in a console window, the loop will exit. Before you are able to launch the node, you still have to compile the C++ source code.